beautiful, absolutely beautiful, and they can't beat it, right? They can't beat it. They can't show any curvy water. Like, you ask them for curvy water, and they'll show you a drop of water. A drop of water. That's their
Right.
best shot. That's their best. That's the best effort they've got, is like a drop of water. Or they show that whatever that CGI imagery on the ISS is of that
Hmm.
water sphere. But that is the absolute best they've got.
Right. Surface tension, that you can see some form of it bending around the edges of that, but you can't say it's not. You can't ever say it goes into a ball in any kind of sense that it'd be flying through a vacuum and retaining its
No,
form and all that. There's no way.
no. But look what happens to it when you put a second drop on it, or a third drop, and see what happens to it. It won't hold its shape at all.
No. Well, if planes can't even fly in straight lines, what are they going to do? I mean, how often do you ever see a plane not flying in a straight line? That's the question, right? You look in the sky,
Um,
these plane trails are straight as fuck.
that was
How are they claiming
laughable
that they all
yesterday.
curve?
That was absolutely laughable yesterday, listening to that, plotting
Right?
a course between, was it New York and Florida, and he's looking down at the
Right.
map. Oh yeah, we're going to allow for this, and we're going to allow for that, we're going to allow for the other thing.
And the way
Absolutely
he
crazy.
skirted around it,
Yeah.
having to, well, if you plot it on the land, well, no. And I was listening to the conversations that followed because I started this whole thing about the jet that has all these capabilities like 2 nights
Uh-huh.
before that, and people were on about it. And you heard every baller come in and give their attempt at how to explain it, and they were all working with, either just avoiding it completely, like Bacon was doing, or trying to come up with illusionary wins or some kind of way that, I mean, because that really kills the conversation. If they can't explain why the plane only sees it
Mm.
as stationary, then they've got a
That's why.
problem.
Yeah. That's why I had to jump in, because when kept on focusing on the towns and the flight path and all that sort of stuff, I had to jump in and say, well, just fly north south,
Right.
perfect straight
There you
line.
go. And
Don't
he
worry
couldn't.
about the towns.
He couldn't answer that. He couldn't.
No,
He was like,
no.
oh no, oh no.
Oh no, we can't do it. We've got the winds. We
Oh,
always have to worry about the
right.
winds.
Yeah. Like these winds are in a conspiracy to keep the
Oh,
jet always seeing a stationary Earth.
they are.
That's
They
how
are.
simple it is. Every time, in fact, every time you get in a plane, you should see the Earth moving below you, regardless of the jet's capabilities. But none of them have any experience or knowledge of what a jet can and can't do. But then they're completely positive that a jet can never see the Earth move.
Mm-hmm. Mm-hmm.
Like you don't know the capabilities of this jet, but you're already assuming that no
Yeah.
matter how far it travels, how many tangential speeds it travels, it's always going to see a stationary Earth. But then you're completely positive the Earth moves at the same time.
And then I don't know if it was you or Merle that brought up, or it was Bacon, as I heard my ears pricked in. It's just like, we'll throw a ball in a room that has no wind
Oh yeah,
whatsoever.
that was Bacon. Yeah,
Whatsoever. Yeah, that was Bacon. You heard that again. It's just like, all right.
Coriolis in his room.
Yeah,
His
we
room
can.
moved out from underneath the ball.
And he made a positive claim that we could actually
Right.
measure the Coriolis, right,
Yeah, you do it enough times.
over a
You get an
hundred
average.
meters. Yep. And I went, okay, then what's it going to be? 1,000 inch, 1 millimeter? Like, how are we going to measure this, Bacon? Like, give me the figure.
Right.
Oh, no way, Jose.
But the jet that has 40,000 pounds of thrust resistance and can do whatever it wants,
Mm.
however long it wants, with just like total maneuverability. There's no way it could ever get out of sync with the Earth enough to see any Earth movement. And that's why I love that argument, because they have to run around trying to figure out. And if they really believe it, it must just be a conundrum that they must just like have the big cogdice with it, or they just can't. They just have to believe that the ridiculousness of the excuse, because
Yeah.
it should kill it. It should kill any logical belief in it for them if they really think about it.
Yeah, and they kept on jumping all over the place, going to bullets and helicopters and drones and
Uh huh.
balloons and everything. It was all over the place, really,
Yep.
trying to trying to drag you into the weeds and get you talking about something else other than what you brought up in the first place.
I have to
find
hand
it
it to
interesting.
Bacon. He's good. He's good at it. Go ahead, sorry.
Coriolis conversation, aeroplanes, whatever. It goes from, like you said, bullets to balloons to powered flight to non-powered flight. Depends whether you're traveling latitudes or like it's just that the same thing goes round and round and round. And the room is just split down the middle. Half the people go, your argument is utter horseshit. It makes no sense whatsoever. And the other half of the room are completely sold out to it and claim to understand it and claim the other half are a bunch of morons when the other half are thinking it's logically ridiculous. It makes no sense at all. It's like no one's got a foot on either side of that argument. It's just you're black or you're white and that's it.
Yeah.
You mean on their side? Or just on anyone's side? You mean the ballers are split? The ballers themselves are split?
No. Like the people, the baller side who want to say we're spinning around, that they all will just buy into the same.
Well, they have to. Yeah.
Bounce around. It's like flubber. It's like that little bit of green thing, just bouncing around the entire argument, never sticking to one particular part of it. Just they'll take you from snipers to jet planes to hot air balloons and wind and jet streams and God, I mean, we've all heard it 100 times, and they'll all just ping around like flubber inside of that narrative. And those outside of the narrative just look at every element of it and go, no, that's not how the real world works. But there's kind of no one in the middle. It's like you're sold out to it or you're completely in disbelief of it. It just puzzles me.
And they'll tell you just don't understand. That's the funny part.
I just don't understand, man.
When you break their logic, they'll be like, you don't understand. This is the way it works, and you just don't get it.
I'm too stupid.
We got Peyton Ashill in the room right now. In fact, he could explain how it is that a plane travels north to south and never sees a moving Earth. How is that possible, Peyton Ashill?
It's all a matter of scale, something you guys don't seem to understand.
No, that we don't understand.
You don't understand. That's exactly what I knew he was going to say.
Seriously. It's all a matter of scale. It's a very simple problem. It's a very simple problem. You guys are taking a minor thing and blowing it up into a big, huge thing.
Case in point. Thanks for proving our point so well.
What's the point? The point is that you don't understand it.
You couldn't write this stuff, could you? You couldn't write it.
See? He's in to save the day, but then kill it at the same time. He didn't save it. He totally made our point for us.
You take a minor force and blow it up into a major force.
What?
You take a minor force and think it's something major.
Here we go. Flubber. Here comes flubber. We're not talking about forces. We're talking about seeing the Earth move underneath east to west, an aeroplane which is traveling north to south.
Why would you expect to see that?
Oh, my God.
Well, because the Earth is supposed to be moving.
Why wouldn't you?
Listen to the scenario. Because the Earth is supposed to be moving, that's why you would.
Yeah, but when you have an airplane on the Earth, it has the movement of the Earth, and when it leaves the Earth, it doesn't suddenly lose all that momentum.
Right, but then it flies over different tangential speeds that doesn't have the same momentum.
That's right. Exactly.
Yeah, and how long does it take to do that?
Oh, 12 hours.
Well,
I'm
posting some GIFs. I'm posting some GIFs right now. You could have a look at them. There's this F-35B jet that's depicted in one of the GIFs that's uploading right now. It has 40,000 pounds of thrust resistance, and it can fly 1,200 miles per hour, and it can go as fast as it wants. It can fly in straight lines. So if this jet was trying to fly a straight line north to south, and it just kept that straight line and resisted all those winds, those imaginary winds or Coriolis winds, whatever you guys call them, so why wouldn't this be able to see west to east movement underneath it?
Because it has momentum of the air place it left.
Yeah, but then it goes over different tangential speeds, which doesn't match that conserved speed. How do you explain that?
Pilots don't fly in some sort of bizarre reference frame. They fly in a path.
You mean like some bizarre straight line?
No, they fly a given path over the Earth.
Yeah, given. Like, what if he wants to fly a straight line over the whole Earth?
What if he chooses not to travel that given path? What if he goes rogue and just decides to fly north-south?
You still are flying a path over the ground.
Yeah, right. A path over the ground, which is supposed to be moving underneath him. And if he kept a straight line, he would see the Earth moving beneath him. Yes, he would.
God, again, this is a minor
issue. God, like, you can't act like we don't understand. And
no, you don't understand.
You obviously
don't
get it.
No, a typical flat earther who doesn't
understand
anything, who doesn't understand anything about aviation. For fuck's sake.
Mm-hmm.
You think that the airplane taking off the ground immediately loses all its momentum or something?
No, I didn't say that.
It never loses any of
it? I'm using in the GIF below it, it explains that if it keeps its original conserved speed, it messes it up for you because it's got 1,000 miles per hour when it started, and then it's flying into a different tangential speed that has a different conserved speed. So the winds would have to push this plane sideways to either speed it up or slow it down to match that tangential speed. And that's ridiculous. Acceleration sideways for a plane that has this kind of capability as any plane, but one that can resist those kind of winds, is impossible for it to be so magically keeping it within the tangential speed to keep the ground seeming to be stationary relative to its own speed. That's a ridiculous claim that makes your side look dumb.
No, it's you don't understand aviation once again.
No, it's not about me understanding it.
It is
about a straight line. Paths can fly in straight. They can fly in straight lines.
Airplanes fly in straight lines over the Earth. Yes.
Yep.
So what does he do? If he's seen he's drifting to the east, he's going to make a correction to the west and fly the straight line.
No, he doesn't. What if he doesn't make correct? If he doesn't make
then he'll be blown. Then he'll be blown by generally the prevailing winds in the United States are west to east. He'll be blown east bound.
So the winds blow him to keep the illusion of a stationary Earth.
The winds blow. Oh fuck! You're an idiot. See, once again, you don't understand scale. The winds are much. The winds are much stronger. The winds are much bigger effect than the Coriolis effect.
Let me put it this way: you take off from New York and you're heading to the South Pole, okay? And you just head due south, magnetic due south. That's all you do is you hold a heading of due south. The Earth, once you get down to Miami shouldn't be underneath you. It should be, what if it's a 3-hour flight, 4-hour flight? It should be 3,000 miles on the left-hand side of you. It shouldn't be there, but you'll fly straight over the top of it. You will fly straight over the top of it.
Once again, you conflate. You don't understand that when you take off from New York, I've flown New York to Miami several times, and guess what? No, you fly on a given ground path.
Fly to the south. You're heading due south. Forget ground targets, due south. I want to end up at the south pole of the Earth. Okay. So yes, if you would argue, if you're flying to Miami, well, you'll make corrections to chase Miami as it moves. I'm just flying straight to the South Pole. Forget all avionics. I've just got a stick. I'm in a Tiger Moth from World War I. I got no avionics at all. I'm just got a magnetic compass on my dashboard, and I'm flying due south at 120 miles an hour. That's all I'm doing. So the Earth, in your world, doesn't move underneath me. That is nonsense. It'll take me 50 hours to fly there.
But they have to. See, the thing is it doesn't move, and you do fly a straight line from New York to Miami. But they have to explain it that it wasn't a straight line, so they can keep their globe model fantasy.
Again,
how do you explain it in the Tiger Moth? Give me the explanation in the Tiger Moth.
Oh, first of all, the Tiger Moth has nowhere near the range to do that.
Theoretically, it's got big, fuel tanks hanging under the wings. You know the point I'm trying to make. Don't try and sideline it here, man. Just go with the argument.
Well, your argument is silly because that's not how airplanes fly.
Well, the straight lines with compasses. That's how they flew in World War One.
Yeah, that's right, and they didn't fly to the South Pole. I mean, your argument. Your argument is silly, at best silly, because
you have no answer. Just admit it. You have no comeback for that.
Because it's a stupid question.
No, but you have no comeback.
You don't understand how airplanes fly.
You've just got to run away. It's fine. Run away from it. That's cool.
How airplanes fly.
I win, you lose. I win, you lose. It's cool. Just concede.
No, you're an idiot.
Yep. They have to call it stupid and say we don't understand.
Which is
I don't understand. You can't concede.
To watch your reaction.
You have no comeback for my example. None.
I have no comeback for example because it's stupid and that's not how airplanes fly.
You should be able to, then you should be able to demolish me in an argument, but you can't.
I can't because you're too dumb to understand the argument even.
Oh. Okay, cool. I'm going to take that as a win.
You're too dumb.
Of course you're going to take it as a win. No, I'm not going to. I mean, if you guys want to explain how aviation works, then go to a freaking pilot school for a while. I'm tired of explaining aviation to idiots.
You're tired
the speed of light is constant in the vacuum. Thank you.
Yeah,
the
you'd have to give up.
Isn't constant. It varies dramatically.
And not in a vacuum. No, it doesn't.
Who's talking about a vacuum? Who's talking about a vacuum? I'm not talking about a vacuum. Am I? Why would I be talking about a vacuum?
Then your statement is silly because everybody knows that.
I never have spoken. I never mentioned a vacuum.
Bandy, you're silly now. I'm silly, and now you're silly as well.
Yeah, he's silly as well. You guys are all silly because you think the Earth is flat. Oh, by the way, in 3 days now, are you guys going to go measure the Earth and prove that your whole fantasy is wrong, or are you just going to say no because reasons?
I thought they already measured the Earth 1,000 years ago. Why do you have to wait 3 days?
2,000 years ago. Well, 3 days. You don't. You can do it any day of the year you want. It's on the equinox is an easy one because the sun is over the equator.
You're just stupid. You don't understand how equators work.
So the answer is you're going to run away from it. Gotcha.
And just stop generalizing. I didn't say the Earth was flat. I just think your narrative's nonsense.
Let's just change the subject to this test I'm going to do in 3 days because I can't defend the argument about this plane that would easily show the Earth moving, but there's no way it ever would. So you lost.
It won't though, especially a tiger moth flies way too slow.
Ends the conversation.
A tiger moth flies way too slow to see any effect. It would be like driving your car. So when you're driving your car down the highway north south, do you have to correct for Coriolis effect?
Oh yeah, cars are the same.
I'm in contact with the road.
We're supposed to believe that cars are planes. So how stupid do you think we are? Come on.
Yeah, pretty stupid actually.
My car's in contact with the road, you idiot. What on earth are you trying to illustrate with that?
Yeah, but you still have to correct for it. I mean, don't you have to like turn way left because it's.
No, your example is farcical.
It's the same thing.
It's farcical.
So is yours.
I'm stuck to the road. I'm stuck to it. I'm stuck to the road. The airplane's not stuck to anything.
So was the car compared to the airplane what convinced you? Is that why you're convinced it's the same?
No, because I'm a pilot and I know this shit and you don't.
Yeah, good on you.
Are you an actual pilot, NASA?
Yes, I'm an actual pilot.
Cool. Where do you fly?
I have an actual pilot license.
Oh, so you don't fly now though?
Not currently, no.
Okay. What sort of planes have you flown?
You can ask go ask Rakia. He likes to brag on my history.
Why would I ask him when A, he's not here, B, you're the pilot? Why would I ask him?
Because he's like fascinated with me for some reason. See, I told him, and then you see the problem is when I tell you guys a bit of this, you dox me, and then go, oh, and Rakia goes, oh, he flew KC-135s, we fuel SR-71s, oh.
I actually asked a genuine question.
I'm sorry. Yeah. I'm sorry, Bandy. You're correct. I'm sorry. I'm late. It's late. I've been talking to Rocky earlier, and it pissed me off. I flew KC-135s. It's a Boeing 707, basically air refueling airplanes.
So in flight school, did they tell you that it's just like driving a car?
Sort of. At times, it can be.
That's interesting.
Actually, they didn't mention anything about Coriolis in flight school, except for in meteorology class where they talk about it. Yeah.
I wonder why.
Because it's a minor effect and you don't have to fucking worry about it.
Or because it's not moving. Maybe that too.
No, they actually mentioned it again. Hold on a second. They actually mentioned it in meteorology class because it's the main reason that the winds blow in the patterns they do. The east to west winds over the United States and over Australia, from what I understand, are Coriolis.
Seriously, I'm not being a smartass here. Does he not find it curious that in flight school they don't mention it, but they tell you it to do with the weather?
That's correct.
Like that does that not ring a little ding-a-ling-a-ling in the back of your head?
No, it doesn't, because it's a very, very minor effect to airplanes. Especially,
you know on Walter Bisland's website, he says that over a 5-hour trip, you'd be 500 miles off course due to Coriolis. Yeah. So is that minor?
I haven't seen that. In the meantime, you are worried about more. You are maintaining the course over the ground. To the Coriolis effect would seem like a minor crosswind.
Okay, let's just hypothetically, if the Earth was stationary underneath you while you were flying, is that not another reason possibly that they wouldn't bother to tell you about Coriolis because it's not real?
They tell you about it
to do with the weather. To do with the weather. It's the weather, right? Winds and weather. Well, they can attach any narrative to that. But flying the aeroplane, they don't mention it. That's bizarre.
Not really, because it's a minor effect.
Paid NASA show. I have a question for you. Honest question.
What's that?
Could that minor effect happen on a flat Earth?
No.
Honestly, no.
No.
Hey, tell me why you think it can happen.
Because what do you know about Coriolis?
Yeah,
not a lot.
It's because Coriolis. Hey, Godric, Coriolis only happens because the Earth moves below the projectile. So on a flat Earth, it wouldn't move.
No, the reason Coriolis happens because the Earth rotates. That's correct.
Okay, I have two answers to Coriolis, different answers from Globers. The first batch of people at Globers say, no, it doesn't have an effect. It's just a visual effect. It's not a real effect.
No,
the second people say,
no Globers say that.
Yes, they do. Yes, they do.
If they do, then they've been they misunderstand the issue.
The second batch of Globers say the bullet does deviate, and you have to account for it if you're a sniper. That's what the second batch of Globers say. If we shot a bullet straight up, it would fall back down according to the spin of the Earth. Right?
I can't talk about sniper school. I've never been a sniper. I have seen naval charts, though. I have seen the charts for naval guns that do account for Coriolis effect.
At 1,000 yards, how much does Coriolis affect if you're going north to south or south to north?
I don't know.
Well, hang on.
I'm
This is
not
science.
a sniper.
This is science now. This is science and math. So we would know this because we're intelligent. We would know those coordinates, those measurements. So let's find out. It shouldn't be hard, right? We know the spin of the Earth, right? We can measure it. So we should know how much a bullet would deviate over 1,000 yards north to south over the equator, right? Because it's science.
And?
So let's find out and test it. That's what I want to do. And I don't want to put anything on your plate, but you could know that, and then we can get the number, and then we can test it.
I don't find they always talk about snipers interesting, though. I'm sorry.
You can take the sniper out. We can use the compound longbow. Okay, you don't have to say sniper. Okay, if that is not a good word, you say a bow and arrow over 1,000 yards, or a long distance rifle, right?
And what's the answer?
Let's find out, because I want to put it to the test. That's all I want to do. I'm going to get the numbers and then test it, see if it's legit.
Okay.
That's all.
Fine.
And I'm interested, and it's interesting to me that you said it can. Hang on, you said it can't happen on a flat plane. So I'm very interested in doing that, because how do you know it can't happen until you test it?
Well, Godric, they would say you're not on a flat plane, so whatever results you get are the results for a globe Earth.
I'm just basically asking the globe to prove what you're saying is going to be true. Is it going to deviate? Is the bullet going to deviate? Is the arrow going to deviate?
Godric, let me explain something to you. There's lots of reasons that a bullet might deviate from its path, right? And the reason they have to claim that it's Coriolis is because the laws of physics on a globe would require a long distance projectile to have some deviation due to the different tangential speeds of north to south. You see what I'm talking about? You get it? You'd have to go over long distances to see
but that's not
a great deal of deviation. So the way that they could prove it, the way that this could be proven, is to have a jet like the one I put in the live stream mimic the path of a bullet over many more tangential speeds.
You understand
so
that
there would have to be ground movement west to east underneath the jet, and they could show that the Earth spins if it's spun very easily with a jet that goes over many tangential speeds north to south, but they refuse to even admit that there'd be a chance for a jet that's very powerful to even see ground movements, which in my mind proves that they know it doesn't spin, because they're totally positive a jet like this could never show it.
You understand that a jet is not a ballistic object?
Yeah, that's what I'm saying. It mimics the ballistic object.
Well, why don't you just use a ballistic object?
Because I'm talking about a camera. You could put outside the window or below the jet and show this Earth. You could do that if you could manage it. All right, sure. But a ballistic object doesn't go over longer periods of time over many different tangential speeds. So the claim could be that you're showing it. I'm talking about you could fly from the South Pole to the North Pole in one straight line, and they would have to claim that the winds are magically making this plane either speed up or slow down depending on the tangential speed it's flying into, which is ridiculous. This debunks the globe positively and definitely, and it ends the conversation for anybody that tries to explain it.
It doesn't debunk anything. No,
because listen to your explanation. Listen to your explanation.
Your explanation is that the airplane is not a ballistic object. You don't understand how airplanes fly. You think that you think they're going to just lock it into one position? For fuck's sake.
That's what I think.
No,
you don't think they can lock into one position?
No.
You think the winds are gonna make him have to go sideways just to match the tangential speeds perfectly? You think that's what happens?
Yes.
Hang on.
That's how ridiculous you sound, and you don't even realize it.
You either are an idiot or a Poe. I haven't decided which.
You don't need to call names, okay?
No, it's true. I mean, if he's going to come up with this stupid, he has no idea how airplanes fly. I mean, I've always
I have no idea.
Hang on. Let's go backwards a second. Listen, I don't
planes can't fly in straight lines.
Perspective. I don't know how to prove your point with a plane, but what if we use the catapult, like those catapults, like with the big rubber bands? We can
because
shoot
it doesn't go far enough. It doesn't go far enough. You need to go over many miles more than that.
No. There is going to be a deviation at 1,000 yards.
They've noticed it's effective with naval guns.
Yeah,
there's going to be a deviation at 1,000 yards.
British noticed it.
There's many reasons that it could deviate. It could be wind. It could be all kinds of reasons that it deviates. And they'll claim it's Coriolis.
No, because if it's Coriolis, then we would see the repeated same deviation every time, more or less. The wind might blow it off course, but the Coriolis would be a more deliberate, obvious result. Okay, that's how you.
Yeah, but you'll find snipers that claim there's Coriolis, and then you'll find snipers that are flat earthers that say they've never been taught it. There's no reason to think that there's barrel distortion. There's all kinds of reasons that this could be deviating. There's so many different things that you could attribute it to, but they have to claim it's Earth spin because that's how it would work if we were on a globe. I'm saying that your efforts would be probably better put in just understanding it first.
And understanding, do you mean disregarding it, saying it doesn't exist because...
No, understanding the argument from both sides, because this has been going on for 7 years now.
The problem I have with a sniper, like if you really believe a sniper has to account for Coriolis, here's the problem I have with that, okay? This is like common sense, right? So the sniper's on a hill that's shooting north-south, right? Then he has to account for Coriolis, right? But let's say his target changed. Let's say he's in a battle zone, right? And he has to change the target to a west-east or a south-north. So now he has to readjust for Coriolis every time. He would be dead sniper. He wouldn't even be alive if he did that. He would be dead. He couldn't do that fast enough.
You still have Coriolis east-west, only it's a rise-drop issue.
Oh, you say it as if the sniper was in the middle of the battle, and accounting for Coriolis would kill him or something. I mean, snipers usually aren't in a hurry, right? I mean, they're far away. They're not in the field of battle. And of course, I mean, if he's accounting for the win, which they do, and he's gonna make the next shot, and the wind changes, he's gonna have to readjust for that. So why can he readjust for the wind, but he can't for Coriolis?
This is globe logic, right? To start using other things that we're not talking about, start using wind and other things to mass confuse the situation, so we can't even tell.
Because the wind is a much larger effect, especially on airplanes.
That's actually not the point, Godric.
But the point is that you're talking about something else that I didn't talk about, because you're trying to use the result, so you can't even get a result. This is the globe logic. I said Coriolis.
I was responding to your argument
Listen, Bacon. It would be harder. It would be harder to have to deal with Coriolis and wind, not easier. Okay. So my point that the sniper couldn't deal with Coriolis shooting different directions. Now it's doubly more impossible to do it if you had to deal with wind and Coriolis. That's my point.
Yeah, but
so don't think that you adding wind is going to make it make sense. It makes less sense now.
Godric,
do you know? Like, just remember one thing. Hang on, at the beginning of this conversation, I said every Coriolis conversation goes the same way. It bounces from bullets to arrows to balloons to jets to wind to movement to you're stupid, you don't know, and that is exactly what this one has done for the last 20 minutes, 25 minutes. So nothing new under the sun.
No, I was not actually saying what the win would be for Coriolis. I was just referring to Godric's argument could be used against wind. So if you're saying, well, if a sniper will have to account for Coriolis, he would be dead. I could just say, well, if the sniper has to account for the wind, he would be dead. Like, both things is going to make it longer for him to have a good shot.
You are proving my point. You're proving my point. He couldn't account for all that in a war zone.
Why?
He would be dead.
Yes, you better if you want to be a good sniper.
Yeah, the thing is, Godric, and even like, if you think about it just a little bit, shots that have to take into account Coriolis are shots from a very, very long distance, right? So if the target is moving, but is very, I wasn't finished. So if the target is moving and it's very far, that's gonna be a very tiny difference in angle. It's not like the target. It's not like
listen, I'm gonna stop you because you're speaking nonsense. Okay.
Hold on, Godric, hold on. Let him finish his point and then correct him, please.
Okay, go.
Yeah, it's not like the sniper is aiming north and suddenly he has to aim east. If he's aiming at hundreds of miles away, the target is not going to move by that far. So even if he's having to account for Coriolis, I don't think changing the position of the target is going to have him to readjust Coriolis, because that would be a pretty negligible difference. How am I saying?
Yeah, you think it'd be negligible, so it wouldn't. So you can't tell. So it's almost like he's on a flat plane that's stationary.
No,
right?
You completely missed the point. I'm not saying you wouldn't tell Coriolis. I'm saying he would, but if his target is moving and he has to readjust for Coriolis, I don't think he would have to readjust for Coriolis. The first adjustment that he did probably is going to be useful for the next shot, because the target is going to be more or less in the same direction. You don't aim east and suddenly you aim north, because you're talking about very long distances. The target doesn't move like 100 miles north to 100 miles east. Do you understand?
Hang on. Since you're an intelligent person, you have to give us now what the deviation at 1,000 yards is. And people do shoot at 1,000 yards, and it's not miles. Don't put mass confusion. This is a real thing. You can shoot a gun, artillery, 1,000 yards. So you, with the globe model, should be able to give us the numbers on how much that would deviate, and we should be able to test it. Don't say, "Oh, it's negligible. Oh, you can't tell."
I'm not saying that's negligible. That's not.
Godric,
You're not following.
Godric, let me tell you. These guys, wait, let me just tell you something, Godric. These guys would love to talk about the Coriolis effect as it applies to projectiles. They can figure out the numbers for you. They're happy to do all of what you're asking, even the tests. They'll do anything you want when it comes to projectiles. But once you start talking about airplanes over long distances, not able to see any ground movement,
airplanes
they will run away and try to make it go back to projectiles. So don't try to make the conversation just focused on what they want.
Airplanes are not ballistic. You make small corrections all the time to
see how ridiculous they get? See how upset they get, Godric?
Are not
this is where we want them. This is where we want them, right here.
Airplanes are not ballistic.
We were talking about planes, but just quickly, right? Because I want to get back to the planes where Dave had it, right? Because you guys have successfully got us into the weeds, right? So we're going 1,000 yards, right? And how much Coriolis are we allowing for over 1,000 yards, Bacon?
I need a little bit more. I need a little bit more information.
No, you don't. No, you don't. It's north to south. The equator is 1,000 miles an hour. We know the measurements and we know the direction. So you should be able to do the math on that.
No, I still need a little bit more information.
An average, Bacon. Just give me an average. Right?
You mean an estimate?
And let me help you.
Hold on, Godric. We're not talking meters here. We're not talking yards. We're talking maybe an inch. Maybe an inch over.
I don't know. I'll know that.
And
I'll know that once I.
Can
I answer you guys? You guys are asking me, but you're not. You're speaking over me all the time.
No, I don't want to speak over you. I just want to just stop it for a second. We're not talking about wind, okay? And we're not talking about moving targets, genius. We're talking about a stationary target moving over supposedly spinning Earth at 1,000 miles an hour at the equator, north to south or south to north. Okay, you can pick which direction.
Godric, you can Google it. It says 3 inches. Okay,
3 inches. 3 inches. So 3, which is pretty much next to nothing anyway. And they're shooting at the center of mass. They're not taking headshots. It ain't critical. Or they're not going between the eyes. They're going at the center of mass here. All right. So this whole Coriolis argument with snipers is absolutely ridiculous. It is absolutely ridiculous.
Snipers disagree with you.
So no, they don't. I have done a lot of sport shooting, right? And never once did Coriolis ever come into it over a kilometre. All right. I've done a lot at the Kerrang shooting range. All right. I've done a bit. Okay. Coriolis never came into it, Bacon. Ever.
How do you know that?
Not once. Okay.
Now, first of all, what we should expect to measure in a kilometer? What would you expect to?
But the thing is, hold on.
I'm trying to answer.
Hold on. As a sporting shooter, right? You are aiming between the eyes, right? You want that headshot. You want the bingo shot, Bacon. You're not going for the center of mass. And Coriolis never came in to the equation with all the lessons that I had. Not once. The only thing that came into it was the wind speed, pressure, and the rifling of the gun. They're the only things that you had to take into consideration ever. Never.
Are you a sniper? Are you a sniper?
I was a sporting shooter. All right?
Yeah. Have you ever shot as far as a sniper had?
I just told you the distances. I was shooting between 1 kilometre and 1.5 kilometres at times.
Right. So snipers shoot longer than that, right?
Is 1,000 yards. That's 1,000 yards, Bacon.
Right. You know that the speed of the bullet also determines how much Coriolis you're going to.
All right. So just negate what I've said because I've shot with people that have.
What would you know, Ben?
That have fired high caliber rifles and smaller caliber rifles. Never was it taken into consideration. So you can negate my experience.
I'm not negating your experience, Benzo.
Bacon. I've got Benny. Give me one sec. Bacon. What's the difference between
that's the third person that is speaking? I can't get my answer yet.
What's the difference?
That's the third person speaking, and I couldn't get my answer.
What's the difference between a sniper and a long distance sporting shooter? What's the difference?
I don't know.
Someone's not shooting back at you?
Zero.
Yeah, no.
Oh, there's
no.
so is part shooting. So someone that's
there is a
the,
difference.
oh my fucking god! If I can't speak, I won't be here.
There is a difference, FE, because as a sporting shooter, you were going for the bullseye.
Yeah, you're trying to shoot a tight group. Yeah,
exactly right. Not the body of mass. Not the body of mass.
I was more, mate, just trying to illustrate. You know, one person shoots 2 kilometers at a target, someone else shoots 2 kilometers at a person's head. Yeah. Not a lot of difference in the training there. You know, it's the same mechanical process. And now he's run away because he's upset. He's upset. Yeah. Oh well. Anyway. Well, he wanted to. Him and NASA wanted to take it to bullets and stuff, which I know. We kind of.
Yeah, they're happy to do that. They're happy.
That's all they ever do.
We kind of let them do it. I fell into the trap too, but anyway, whatever.
Godric, do you get that the whole idea of it is that the Earth is spinning below the object and it have to go over lots of different tangential speeds because those circles get smaller north to south, right? So they would have to fly over like a long distance to really be like a effect that you could possibly measure.
I understand your intention. Like I don't
be worth testing.
I understand your intention. I don't understand the measurements of that, how that would vary. I really don't know. I was trying to get the measurement for 1,000 yards. Someone said they Googled it. It was 3 inches. I'm not okay with that. I wanted them to tell me why it's 3 inches and at what point can you tell the difference. If it's 3 inches at 1,000 yards, maybe we need to go 2,000 yards. I don't know. But obviously you can't tell if it's only 3 inches.
Well, see, that's the thing is there's lots of reasons that it might deviate for you know, you can ask a sniper that's a flat earther that will say, yeah, there's lots of reasons that it would be barrel distortion. It could be wind conditions. It could be just the drop. I mean, you know, whatever it is, but to call it Earth curvature or Earth spinning underneath it is what they have to do because that's what would happen if the Earth were turning. So every time I bring up the whole idea with the jet that flies north to south over several different changes in tangential speed, they say, oh, that's not a good way to test it because it's not a ballistic and it's not the same. It wouldn't work the same. But actually, it would work much better because you can control the jet to go in a perfectly straight line over many more tangential differences. You'd be able to show the Coriolis or the spinning Earth below you very easily. And they know it. And so they have to try to veer the conversation back to ballistics because they have a way of tricking it or making it seem like it could be because they have people claiming they're long-range snipers that use this effect, even though it's not in any training manuals or any practical use manuals whatsoever of how to take it. Or they'll put it in there in some of them just to you know, promote the globe line.
Thank you for that. I don't know how to measure it in a plane. I really don't. I think you should be able to measure it with a bullet or a bow and arrow. If it's only 3 inches, honestly, you couldn't tell that. But here's the thing. Notice how they have to insert wind because that's the one way they confuse the measurements so you can't tell. So here's the thing. To control, you can control for the wind by shooting when there's less wind. And if you continually shoot different times, different wind conditions, you can see the difference where you can hit a certain spot. You know, the wind will, let's say, deviated X amount. And if there's Coriolis, you should be able to determine what that Coriolis is. I just want to know if you can determine what it is. Don't tell me, oh, wind, oh, moving targets. This is just confusing. Not being able to get to determine what it is. I want to see if you can determine what it is. Period.
Well, yeah, because there is difference. There is many factors to vary in. That's the reason it works for them, because they can use those factors in their favor if they need to, or discard them if it doesn't work for them. That's how they do everything.
Yeah, they talk about it like it's a real thing. So show me the real thing. That's all I want to see. You know, and if it's only 3 inches, then we'll have to do it so there's at least more of a difference so you can tell. Maybe you need to go 1,500 yards. I don't know, whatever it is.